Alright, so today we continue from where we stopped in building our binary search tree in Java as part of Google interview question. And in the first part, we've completed creating the file, and we've also completed the insert method, and we have done it completely. Today we are going to actually be looking at the contains method. So we actually want to check if this tree contains a particular key, right? So we need to write a method that will take an integer, and it will check through the tree to check if this integer is contained in this tree. Okay, so that is what we are going to do now. Remember, if you've not subscribed to my channel, click on the subscribe button below this video to subscribe. In this way, you kind of get notified when I make new lessons, and also you kind of encourage me to keep making these lessons. If you have any question you want to ask me, write it down below this video in the comment box, as you can see there. Alright, so the method we are going to write now is a contains method. We want to check if a particular integer key is contained in this tree. So we are going to say public boolean because we are going to return true or false. True if it's contained there, and false if not. So we say contains, and we say int key, right? So as I mentioned before, so you also use good comments to specify the end of the function, end of contains. All right. So the first thing we want to do, and also somehow this contains function also derives from this place. So the first thing we want to do is to check if it can either be that this key is the root, or this key is not the root, right? So if this key is the root, then we return true. If not, we check is less than the root or is greater than the root. So there are three conditions: is equal to the root, is less than the root, or is greater than the root. So we set up the if-else statement to capture these three options. So we say if key is equal to the root, right? So if this key is equal to the root, which is this dot data, so at this point, what we are going to do is to just return true. Okay. So else if we're now going to check if it's less than the root, if key is less than the root. So we search on the left if key is less than the data. In this case, is less than, therefore we are going to put a comment here that says search the left subtree, and fine. And let's just write the next else statement, after which we now start adding the body. Else, so this is just one last option. It means it's greater than the root, and in this case we are going to search the right subtree. So now this key is less than the data, right? Just give me 1 second. Okay, so let's continue. Just wanted to make sure everything is okay here. Okay, so if the key is less than, we are going to the left subtree. So if we get to the left subtree, there are two options. Either the left subtree is null, or the left subtree is not null, right? If the left subtree is null, then it means the key does not exist there. So let's say if this dot left if this dot left dot data, if this dot left is equal to null, At this point, we are going to return false. The reason is because for us to get to this point, it means that the key was less than the data and it's supposed to be in the left subtree. But when we get to the left subtree, it means the end of the tree, there is nothing there. So it means the key is not there. However, if the left subtree is not null, that is if this dot left, if it's null or is not null. So let's not add any more if. Let's just say let's just use an else statement. We now know that there is some tree in the left subtree. So we do a recursive contains. So we just say return contains return this dot left dot contains, and we pass in the key. So at this point we recursively search the left subtree for the key. So we are done with the left subtree. The next thing we are going to do is to check the right subtree, and the same way we are going to check if this dot right is equal to null. If it's null, then it means there is no key in the tree, so we just return false, right? Good. Now, if this is right, the right subtree contains some tree there, then we need to do a recursive search, and we just say else. We simply say return this dot right dot contains, and we pass in the key. Okay. So basically we are done with the contains methods, right? So the next thing we want to do is to do an in-order traversal of this tree. But since I'm running out of time, I'm going to continue with that in the next lesson. So now I've written all of them. So if you look at it, the description box below, find this code, download it, try to see how it works, and I'm sure you'll get understand it clear. So let's continue in the next part, where we are going to write a code for in-order traversal of this tree and also test it. Remember to subscribe by clicking on the subscribe button below, and also like and leave a comment if you have some challenges.